Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the area of a sector practice questions. If you need any extra help in area of a sector, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 46, there's a dedicated video tutorial there on the area of a sector. But in this video, we're going to focus on the video solutions to the area of a sector practice questions, so let's get started. Okay, so question number one. So question number one says the diagram shows a sector of a circle with radius 7 centimeters. So as you can see, this is a sector, and it's a sector of a circle with a radius of 7 centimeters. So this is the center of the circle, so the whole circle, and that's the center, and the radius of the whole circle is 7 centimeters. And the question says work out the area of the sector. So we want to find the area of this sector, and we're to give our answer to 2 decimal places. Now this is a calculator question, so that's quite nice. So let's write down the formula for the area of a sector. So the formula for the area of a sector is beta over 360 multiplied by pi multiplied by the radius squared. In other words, we're going to find the area of the whole circle, so we're going to do pi r squared, or pi times 7 squared, and then we're going to work out 80 360ths of it. So in other words, we would get the area of the whole circle divided by 360 and multiplied by 80, and that'd be the area of the sector. So let's do that. So here we've got the formula, beta over 360 multiplied by pi multiplied by the radius squared. Beta, the size of the angle, is 80 degrees, so we've got 80 over 360 multiplied by pi multiplied by the radius, which is 7 squared. Now again, this is a calculator question, so we can just type this into our calculator. 80 over 360 multiplied by pi multiplied by the radius, which is 7 squared. And whenever we do that, we get an answer of 98 over 9 pi, or 34.208453334 centimeters squared. And the question says to give our answer to 2 decimal places. So if we look at this, that's going to be 34.2, and then we've got 0.8, so we're going to round up, so it'll be 0.21, and that's it. So the answer is 34.21 centimeters squared, and that's the area of that sector. So question number 2 says the diagram shows the major sector of a circle with radius 3.8 centimeters. So as you can see, the radius of the whole circle is 3.8 centimeters, and we've got this angle of 290 degrees, and we've been asked to work out the area of the major sector. So we want to find the area of the sector and to give our answer to 3 significant figures. So remember, we're going to use beta over 360 multiplied by pi multiplied by the radius squared. So we're going to work out the fraction of the whole circle, which is going to be 290 360ths, so 290 360ths of the whole circle, multiplied by pi multiplied by the radius, which is 3.8 squared. So on our calculator, we're going to type this in, and we're going to get that's equal to 36.54370388 centimeters squared. So that's the area of the sector, and we've been asked to give our answer to 3 significant figures. So that's going to be 36.5. So it's going to be 36.5 centimeters squared. And that's it. That's the area of this major sector. Okay, so question number 3, we've got this sector. We've got OAB as a sector of a circle. We've been asked to find the area of this sector and to give our answer in terms of pi. So we've got in terms of pi here. It's a non-calculator question, so I'm putting down my calculator. And we want to find the area of this sector in terms of pi. So in terms of finding the area of the sector, we're going to work out the fraction of the whole circle. So it's going to be 40 360ths. Actually, I know that's a ninth of a circle, because 9 times 40 is 360. So this is a ninth of a circle. So we're going to work out the area of the whole circle and then divide it by 9 to get a ninth of it. Okay, so I'm just going to write down the formula. So remember, beta over 360 multiplied by pi multiplied by the radius squared. So the angle is 40 degrees, and the radius of the whole circle is 6. So it's going to be 40 over 360 multiplied by pi multiplied by the radius of the circle, which is 6 squared. So let's work this out. Remember our order of operations, let's square first. 6 squared is 36. So we've got 40 over 360 multiplied by pi multiplied by 36, because 6 squared is 36. Now I'm going to cancel down this fraction. So let's cancel this down. So 40 360ths. Now I know it's a ninth already, but if we divide both of them by 10, we get that's equal to 4/36. And then if we divide both of them by 4, we get that's equal to 1/9. So that's a ninth of a circle. So we've got a ninth multiplied by pi multiplied by 36. Now we want to give our answer in terms of pi, so we've got a ninth times pi times 36. So let's do a ninth times 36, or a ninth of 36, and a ninth of 36 is 4. So that'll be equal to 4 pi. So that means the area of this sector is 4 pi. So 4 pi centimeters squared, and that's it. So what we done in this question was we worked out the area of the whole circle, which is 36 pi, and then we found the fraction of the circle, which is the ninth, so it's a ninth of a circle, and then if we take the 36 pi and divide it by 9, that's equal to 4 pi, so the area is 4 pi centimeters squared. Okay, let's look at our next question, question number 4. Okay, so question number 4, again, we've got a major sector of a circle, and we've been asked to find the area of the major sector. So we want to find the area of this major sector, so this sector here, and we want to give our answer in terms of pi. So again, a non-calculator question. So again, our formula is beta over 360 multiplied by pi multiplied by the radius squared. So in terms of beta, the angle, so the angle enclosed by the sector. So if this is 60 degrees, so we want to find this angle here. So remember the angles at a point add up to be 360 degrees. So if this is 60 degrees, this angle here will be 300 degrees. So that's a 300 degree angle. And so that means that in terms of our formula, whenever we substitute in the angle, the beta, which is 300 degrees, we get 300 over 360 multiplied by pi multiplied by the radius. So the radius of the whole circle is 6, so 6 squared. So let's cancel down this fraction. So 300 360ths. If we divide both of them by 10, we get 30 over 36. If we divide both of these by 3, we get that's 10 twelfths. And then if we divide both of these by 2, that's equal to 5 sixths. So that's 5 sixths of a circle. So we've got 5 sixths multiplied by pi multiplied by the radius squared. 6 squared is 36, so that's multiplied by 36. So we've now got 5 sixths multiplied by pi multiplied by 36. But we've been asked to give our answer in terms of pi. So let's work out what 5 sixths of 36 would be. And remember, it's a non-calculator question, so we're just going to divide by the bottom and times by the top. 36 divided by 6 is equal to 6. Times by 5 times by the top will be equal to 30. So that'll be 30 pi centimeters squared. Just checking the units. Yeah, it is centimeters, so centimeters squared. And that's it. So that's the area of that sector, 30 pi centimeters squared. Okay, so let's have a look at question number 5. So question number 5 says, shown below is a sector of a circle with radius x centimeters. So we've got this sector, and we've got the angle here is 45 degrees, and this time we've not been asked to find the area of the sector, we've actually been asked to find the radius of the circle, or this length here, x. So we're told the area of the sector is 18 pi centimeters squared, so it's a non-calculator question, and we've been asked to find the length of x. Okay, so let's write down the formula. So we've got beta over 360 multiplied by pi multiplied by the radius squared is equal to the area. So here beta, well, the angle is 45 degrees, so we've got 45 over 360 multiplied by pi multiplied by the radius, which is x squared, so x squared is equal to the area, and here the area of the sector is 18 pi. So we'll just write down the formula and we're putting it equal to 18 pi, which is the area of the sector. Okay, so we've now got this. We've got 45 over 360 multiplied by pi multiplied by x squared equals 18 pi. Now the first thing I'm going to do is I'm going to cancel down this fraction, this 45 over 360. So let's cancel this down, 45 over 360. Okay, now I want to cancel this down. Now actually both of these numbers are divisible by 45. I actually know that obviously with a right angle that's a quarter of a circle, so 45 would be an eighth of a circle. So we could divide both of these by 45, and 45 divided by 45 is 1, and 360 divided by 45 is 8, and if we actually count up in 45, it's 45, 90, 135, 180, 225, 270, 315 and 360, and as you can see we've got 1, 2, 3, 4, 5, 6, 7, 8. So if we divided both of these numbers by 45 we get 1/8. We could have divided both of them by 5 to begin with, and we would have got 9 over 72, and then divided both of those by 9 to get that's equal to 1/8, and so on. So this is an eighth. If we cancel down this fraction, this is an eighth. So we've got an eighth multiplied by pi multiplied by x squared, the radius squared, which is x squared, equals 18 pi. Now we want to solve this equation. We want to find out what x is. So actually if we wanted to solve this equation, the first thing I'm going to do is I'm going to divide both the left hand side and the right hand side by pi. Because if I divide the left hand side and the right hand side by pi, so divide by pi and divide by pi, on the left hand side, well, pi divided by pi would just be 1, so it's going to get rid of that pi, so we're going to be left with an eighth multiplied by x squared, just getting rid of that pi on the left hand side, and on the right hand side we had 18 pi, dividing it by pi would just be 18. Some people would just cancel them out, they just cancel out that one and be left with an eighth multiplied by x squared equals 18. Okay, so we've now got an eighth multiplied by x squared equals 18. Now I'm actually just going to write this again over here, because if we carry on our working out we're going to go into the answer section. So here we've got an eighth multiplied by x squared equals 18. Now we want to get the x squared on its own. We want to get rid of this multiply by an eighth. So what we're going to do is to get rid of multiply by an eighth, we're going to divide both sides by an eighth. So we're going to divide by an eighth and divide by an eighth. So we're going to do, if we divide the left hand side by an eighth, we get rid of the multiply by an eighth. So we're just going to be left with the x squared, and that's why we've done that. And that's equal to 18 divided by an eighth. And if we do 18 divided by an eighth, that's the same as 18 multiplied by the reciprocal of an eighth, which is 8 over 1, or 8. So we just need to do 18 times 8. And if we do 18 times 8, let's see what we get. So 18 multiplied by 8. 8 times 8 is 64, so put the 4 down, carry our 6. 8 times 1 is equal to 8 plus 6 is equal to 14. So that's 144. So here what we done was we divided both sides by an eighth. On the left hand side we were left with x squared. On the right hand side we done 18 divided by an eighth. Well, how many eighths go into 18? Well, there's obviously 8 eighths in a whole, so in 18 there'd be 144 eighths. Or another way to think about this is, rather than dividing both sides by an eighth, you could say, well, rather than here we've got multiplying by an eighth, which is the same as dividing by 8, if we just multiply both sides by 8, and we would get x squared equals 144. Now we want to solve this, so that means that x would be equal to, now here x can only be a positive value, it's the length of this side, so we're going to square root 144, and the square root of 144, x is equal to the square root of 144, which is equal to 12. So that means that x would have to be equal to 12, because here it has to be a positive number. So x is equal to 12 centimeters. And that's it, we found x, the radius of the circle, it's 12 centimeters. Okay, let's look at our next question, question number 6. So question number 6 is a calculator question, so I'm picking up my calculator again. And we're told the area of the sector below is 2.48 centimeters squared. I've been asked to find the length of y, so we want to find the length of this side. So here, this is just like the last question, but it's obviously a calculator question. So the area of the sector would be β over 360 multiplied by pi multiplied by the radius squared. And so that's how we find the area of the sector, and that's how equal to the area. So here, β, that's the size of the angle, which is 39 degrees over 360, multiplied by pi, multiplied by the radius, which here is y squared. And that's equal to the area, so the area of the sector is 2.48, so 2.48. Okay, so we've now got this, and we want to solve this equation. We want to find out what y is. So let's divide both sides by pi to begin with, to get rid of the pi here on the left-hand side. So let's divide by pi and divide by pi. So on the left hand side, if we divide it by pi, it gets rid of the times by pi, so we're left with 39 over 360 multiplied by y squared, because we've divided by pi to get rid of the times by pi. And on the right hand side, if we take our 2.48, so our 2.48, and divide that by pi, that's equal to 0.789408, and so on. So I've left out my calculator display. Now we want to find out what y is, so we want to get rid of this fraction here. We could do 39 divided by 360 and write that as a decimal number. So we'd end up with this decimal number multiplied by y squared equals this decimal number, and then divide both sides by that decimal number. Actually, I'm going to do that. So I'm going to do 39 divided by 360, and that's equal to 13 120ths, or 0.108333, and so on. And then we've got that's multiplied by y squared, and that's equal to our 0.789408, and so on. Okay, so we've just changed that fraction to a decimal. Now we want to find out what y is, so we want to get rid of this multiply by this decimal. So let's divide both sides by 0.108333, and so on. So divide the left hand side and the right hand side by that, and let's see what we get. So on the left hand side, we'd just be left with y squared, because we divided by that decimal to get rid of that multiplied by the decimal. And on the right hand side, if we take our 0.789408 and so on, and divide it by our 0.108333, and so on, we get that's equal to 7.286847856. And that's y squared, that's that length squared. So we just want to find the length. So obviously here we can just square root that. So we're going to find that y is equal to the square root of 7.286847856, and that means that y is equal to the square root of answer, and that's equal to 2.699416, and so on. And that's it, we've found the length of y, and we've been asked to give our answer to one decimal place, so that would be 2.7, so 2.7 centimeters, and that's it. Now in this question, at this point here, when we had 39 over 360 multiplied by y squared equals that decimal number, another approach would have been to multiply both sides by 360 to get rid of the divide by 360 on the left hand side. So you'd be left with 39 times y squared equals whatever that is, and then divide both sides by 39. So that's another approach rather than writing that fraction as a decimal, and that's it. Okay, let's look at our next question. Okay, so question number 7. So question number 7 is a non-calculator question, so I'm putting down my calculator. And we've been told below is the sector of a circle with an area of 5 pi centimeters squared. So we've got this sector, and we've been asked to calculate the size of angle beta. So we want to find the size of this angle. Okay, so let's write down the formula that the area of a sector, beta over 360, multiplied by pi, multiplied by the radius squared, so that's going to be 10 squared, is equal to the area of the circle, which is here given to us as 5 pi. So we've just written down the formula. Okay, so now let's work this out. We've got 10 squared, that's equal to 100. So we've got beta over 360 multiplied by pi multiplied by 100 is equal to 5 pi. Now here we want to work out what beta is, so let's get rid of this pi. So let's divide the left hand side by pi and the right hand side by pi and see what we get. So on the left hand side, if we divide by pi, we'll be left with beta over 360 multiplied by 100, because we've divided by pi to get rid of the times by pi. And the right hand side, that's equal to 5. Now we want to work out what beta is. So what I'm going to do is I'm going to multiply both sides by 360 to get rid of this divide by 360. So multiply by 360 and multiply by 360. So on the left hand side, we multiply by 360 to get rid of the divide by 360. So we're just going to be left with beta. So beta multiplied by 100 is equal to, and now we need to work out what 5 times 360 is. So 360 multiplied by 5. 5 times 0 is 0. 5 times 6 is 30, put the 0 down, carry the 3, and 5 times 3 is 15, plus 3 is equal to 18. So that's 1,800. So we've got beta times 100 is equal to 1,800. So let's divide by 100 and divide by 100. So on the left hand side, we'll be left with just beta, and on the right hand side, we had 1,800 divided by 100 is equal to 18. So beta, the size of that angle, is 18 degrees, and that's it. Okay, let's look at question number 8. So question number 8 says, shown as a sector of a circle, so is this a sector of a whole circle, and the angle is 150 degrees, and the length of this side is 6 centimeters. So that means the radius of the whole circle is 6 centimeters. And the question says, find the area of the sector, and to give our answer in terms of pi. Okay, so let's write down our formula. The area of a sector is beta over 360 multiplied by pi multiplied by the radius squared. Well, beta, that's the angle, so that's 150 degrees over 360, so that's the fraction of the whole circle, multiplied by pi, multiplied by the radius, which is 6 squared. So in other words, the fraction of the whole area. Okay, 6 squared is 36, so we've got 150 over 360, multiplied by pi, multiplied by 36, because 6 squared is 36. Okay, let's cancel down our fractions. So 150 over 360. If we divide both of those by 10, we get that's 15 over 36. And then if we divide both of these by 3, we get that's equal to 5 twelfths. So that means this is 5 twelfths of the whole circle. So this fraction is 5 twelfths multiplied by pi multiplied by 36. Okay, now we want to give our answer in terms of pi, and it's a non-calculator question. So let's work out 5 twelfths of 36, and then that'll tell us what we're multiplying pi by. So 5 twelfths of 36, so let's take our 36 and divide by the bottom, which is 12, and 36 divided by 12 is 3. And now let's take that and multiply by the numerator, the 5. So let's multiply by 5. 3 times 5 is equal to 15. So 3 fifths of 36 is 15. So that means that's equal to 15 pi. And we need to include our units of centimeters squared. And that's it. So the area of this sector is 15 pi centimeters squared. Okay, let's look at our next question, question number 9. Okay, so question number 9, we've been given this circle and we're told that the points A, B, C, D are points on the circumference of a circle, centre O. So this is a circle and we've got the centre of the circle being O, and we've been told that OA, so the distance from O to A is 4 centimetres, so the radius of the circle is 4 centimetres. We're told that angle BOC, so angle BOC is 140 degrees and it's been labelled 4, so that angle is 140 degrees. And then we're told the ratio of angle AOD, so this angle, to angle BOC, that angle, is 7 to 10. So that's fantastic. So we know the ratio of this angle to this angle is 7 to 10. And the question says to work out the total area of the shaded region. So we want to work out the area of this region and this region added together. So we want to work out the total area of the shaded regions. So what I'm going to do in this question is I'm actually going to work out the size of this angle to begin with, this angle here, because we know the ratio. We know the ratio of this angle to this angle is 7 to 10. So this angle's bigger, it's a 10 part in the ratio, and this is the 7 part in the ratio. So let's take the 140 and divide it by its number in the ratio, which is 10. So 140 divided by 10 is 14. And now we're going to multiply by the angle AOD's number in the ratio, which is 7. So 14 multiplied by 7. And it's a calculator question, so that's equal to 98. So that means that this angle here is 98 degrees. Okay, that's fantastic. So we've got the size of these two angles. Now at this point, there's a couple of approaches that we could use to find the area of the shaded regions. One approach would be to add together these two angles, and that'll tell us the angles for the regions that are not shaded. Then we could take that away from 360, and that'll tell us the sum of these two angles, and then work out the area of that sector. In other words, if you kind of move this sector around to join this one, you would then find the area of that big sector. What I'm going to do is I'm going to work out the area of this sector, I'm going to work out the area of this sector, I'm going to add them together, and then I'm going to take it away from the area of the whole circle. So that's the approach I'm going to use. I'm going to find the area of that sector, add them together and take it away from the area of the whole circle. So there's a few different approaches that you could use. The easiest approach probably would be actually to work out the size of these two angles combined and then just work out the area of that sector. So just imagining this sector joining that one and working out the area of that one. That's probably the easiest and quickest approach, but I'm going to do it the other way just because I think on the solutions on the website, that's the approach that I used. Okay, so let's find the area of sector 1. So sector 1. So in terms of sector 1, it's going to be the area is veta over 360 multiplied by pi multiplied by the radius squared. So veta, that's 140 over 360 multiplied by pi multiplied by the radius. So the radius of the whole circle is 4, and that length is 4. OA is 4, so that's 4, and that's 4, and so on. So multiplied by 4 squared. And it's a calculator question, so let's work this out. And when we work that out, we get that's equal to 56 over 9 pi, or 19.547688762 centimeters squared. So we've now got the area of this sector, 19.547 and so on centimeters squared. I've just put on those little dots to show that number carries on. Okay, now let's find the area of sector 2. So in terms of sector 2, it's veta over 360 times pi r squared. So veta is 98, so 98 over 360 multiplied by pi multiplied by the radius of the whole circle, which is 4 squared. And when we work that out, what do we get? I'm just going to change the numerator on my fraction to 98. So I'm deleting the 140 and I'm typing in 98. And pressing equals 13.6833 and so on centimeters squared. So we've now got the area of this sector is 19.547 and so on. We've got the area of this sector is 13.6833 and so on centimeters squared. So we've got the area of the regions that are not shaded, or the sectors that are not shaded. Now what we're going to do is we're going to work out the area of the whole circle. So do pi r squared to get the area of the whole circle. And I'm going to add those together and take it away from the area of the whole circle. So let's do that. So the area of the whole circle, so the whole circle. Well, the area of the whole circle is pi r squared, so that's pi times 4 squared, because remember the radius of the whole circle is 4. Remember this OA is 4, so that's equal to 16 pi, or as a decimal number, it's equal to 50.265 and so on centimeters squared. So that's the area of the whole circle. Now what we're going to do is we're going to take away the combined area of these two sectors. So let's add those two together and see what we get. So 1 plus 2 is equal to the area, this area plus this area is equal to 476 over 45 pi, or 33.23106.896 centimeters squared. So that's what we get when we add this area together with that area. And then if we take it away from the whole circle, the 16 pi, that'll tell us what's left for the total area of the shaded regions. So let's work that out. Now I'm using the 16 pi just because that's easier to type in. You could write down 50.265 and so on, subtract 33.231 and so on. But I've just done 16 pi, take away answer, and I've got that's equal to 244 over 45 pi, or 17.0344135 centimeters squared. And that's it. That's the total area of those shaded regions. Okay, let's look at our next question, question number 10. So question number 10 is a calculator question again, fantastic. And we've been told shown is a sector of a circle with a radius 9.2 centimeters, so 9.2 centimeters. And the area of the sector is 38.4 centimeters squared. And we've been asked to find the size of this angle. And we've been asked to give our answer to two significant figures. Okay, so let's write down the formula. Beta over 360 multiplied by pi multiplied by the radius squared is equal to the area. Beta is the angle, that's what we're trying to find. So beta over 360 multiplied by pi multiplied by the radius squared, so it's going to be 9.2 squared is equal to the area, which is 38.4. Okay, now I'm just going to work out what 9.2 squared is. So 9.2 squared is equal to 84.64. So that's beta over 360 multiplied by pi multiplied by 84.64, and that's equal to 38.4. Now I want to get rid of this. I want to be left with the beta on its own. So let's divide both sides by 84.64. So divide by 84.64, and when we divide the left hand side by that, we're just left with beta over 360 times pi, and on the right hand side we're going to get 38.4 divided by 84.64 is equal to 240 over 529. So you could write it like that as a fraction, or as a decimal number, 0.453686, and so on. Okay, now we want to find out what beta is. So I'm now at this point going to divide both sides by pi to get rid of this times by pi here. So divide by pi and divide by pi. So on the left hand side we're left with beta over 360, and on the right hand side, if we take our answer and divide it by pi, so divide by pi, we get that's equal to 0.144412828. So we've worked out that division, fantastic. Now we want to work out what beta is, so we don't want this to divide by 360, so let's times by 360 and times by 360. So on the left hand side we'll be left with beta, and on the right hand side, if we just do multiply by 360, we get an answer of 51.9886 and so on degrees. And we've been asked to give our answer to two significant figures, so that will be 52 degrees. So beta is 52 degrees, and that's it. That's our answer, 52 degrees. Okay, let's look at our next question. Okay, so let's have a look at question number 11. So question number 11 says, Holly's designed a garden which consists of a patio and a grass lawn. So we've got this garden and we've got a patio here, this sector, and we've got this grass lawn, this green region here. And we're told that the garden, CEF, so that's CEF, the whole garden. We're told that the patio, CDG, so CDG, that's the patio, is a sector of a circle centre C, and the shaded region, DEFG, is the grass lawn. So this is the grass lawn, and we're told the area of the patio, the area of this patio here, is 1.2 meters squared. So that's the area of this white sector here, and the question says to calculate the area of the grass lawn, the shaded region. So we want to find the area of the shaded region. Okay, so if we have a look at this sector, CEF, the one thing that I notice is we've got the radius of it, but we don't have the angle, so it would be fantastic if we knew the size of this angle here. Let's just call it beta. If we knew the size of this angle beta, we could then work out the area of the whole sector. The CEF, we could work out the area of the smaller sector, which we're actually told is 1.2, and we could take it away to then find the area of the shaded region. Okay, so we want to find the size of this angle beta. So let's look at this smaller sector here, CDG. So the area of the sector is beta over 360 multiplied by pi multiplied by the radius squared, and that's the area of the sector. Beta, that's what we're trying to find, over 360 multiplied by pi, and then multiplied by the radius squared. And if we have a look at this sector, if we consider the whole circle, the radius of the whole circle would be 2. So it's going to be 2 squared is equal to the area, which is 1.2. Okay, so now let's work out beta. So 2 squared is 4, so that's beta over 360 multiplied by pi multiplied by 4 is equal to 1.2. Let's divide by 4 and divide by 4. You could actually just divide by 4 pi here, actually. That might be a bit quicker, but I'm just going to divide by 4, and I'm going to get beta over 360 times pi is equal to, and 1.2 divided by 4 is equal to 0.3. Now we want to get rid of the pi, so let's divide by pi and divide by pi, and then we're going to get the beta over 360 is equal to, and then if we do 0.3 divided by pi, that's equal to 0.09549 and so on. And now we want to find out what size beta is, so let's multiply by 360. So let's times by 360 and times by 360, and then we'll be just left with beta. So beta is equal to, if we times by 360, that's equal to 34.3774677 degrees. So that's the size of that angle beta. That's fantastic. So this angle beta, this angle here is 34.377 and so on degrees. Okay, now the question we've been asked to find the area of this green region here, the area of the grass lawn, this region here. So we know the area of this sector is 1.2. If we can find the area of the whole sector, CEF, we could take away 1.2 and that'll tell us the area of this shaded region here. Okay, so let's find the area of this sector CEF. So the formula for the area of the sector would be beta over 360 multiplied by pi multiplied by the radius squared. So in terms of beta, we know that's now equal to 34.377 and so on over 360 multiplied by pi multiplied by the radius. Well, if we consider the whole circle, the radius is 10, so it's going to be 10 squared. So if we type this into our calculator, now I've already got the angle on my calculator display, so I'm going to press the fraction button and put answer on the numerator and 360 on the denominator times by pi times by 10 squared, and that's equal to 30. So that is equal to 30. So the area of that sector is just 30. That's quite nice. So the area of this sector, CEF, is 30 meters squared. That's fantastic. So we want to find the area of the shaded region. So the whole sector is 30 meters squared. This sector is 1.2 meters squared. If we take them away, that's equal to 28.8 meters squared. And that's it. So the area of the grass lawn is 28.8 meters squared. And that's it. Okay, let's look at our next question, question number 12. So question number 12 says, shown below are two sectors. So we've got sector A and sector B, and the sectors have the same area. And we've been asked to find the length of the radius of sector B, x. So we want to find this length here. Okay, so the sectors have got the same area, so we're going to find the area of sector A to begin with. And then once we find the area of sector A, that's the area of sector B, we can then write down the formula and then work out what x would be, the radius of that circle. Okay, so in terms of sector A, well, beta over 360 multiplied by pi multiplied by the radius squared would give us the area of the sector. Well, beta is going to be equal to the angle, that's 15 over 360. Multiplied by pi multiplied by the radius, which is 20 squared. So if we do that, we're going to get the area of the sector. So let's type that into our calculator and work it out. And when we work that out, we get that's equal to 50 over 3 pi centimeters squared, or as a decimal number, it would be equal to 52.3598776 centimeters squared. So that's the area of that sector. Okay, now that's the area of sector A. That's also then the area of sector B because they've got the same area. Now if we have a look at now sector B, the area of sector B will be equal to beta over 360 multiplied by pi multiplied by the radius squared. The area, that's equal to 52.35 and so on. I'm putting my little dots to show that carries on. I'm just a bit too lazy to write it all down. Is equal to beta, that's 290. Because the angle inside that sector is 290 degrees, over 360 multiplied by pi multiplied by the radius, which in this case is x. So x, I'm just going to do a curved x there to make sure I don't confuse it with the multiplication sign, squared. Okay, so we've now got this. We now just want to work it out. Okay, so I'm now going to work this out. I want to work out what x is. Now, there's a few different approaches that I could use. One approach is I could multiply both sides by 360. I could then divide both sides by 290. I could then divide both sides by pi. That's one approach. I'm actually going to work out this part here this time. So I'm going to leave the area as 52.35 and so on. And that's equal to, and I'm going to work out what 290 over 360 times pi is. And when I work that out, I get that's equal to 29 over 36 pi, or 2.5307 and so on. So that's what this part's equal to, and that's multiplied by x squared. Okay, so I've now got 52.35 and so on is equal to 2.5307 and so on. I want to work out what x is, so I want to get the x squared on its own. So I'm going to now divide both sides by 2.5307 and so on. Divide by 2.5307 and so on. Okay, so on the left hand side we've got our 52.35 and so on, or our 50 over 3 pi, and I've just had that into my calculator actually is 50 over 3 pi, and I'm going to divide that by answer because that's on my calculator display already, and I get that's equal to 600 over 29, or 20.689655 and so on, and that's equal to, and on the right hand side we were dividing by 2.53 and so on to get rid of the multiplying by it, so we're just going to be left with x squared. Now we don't want the squared, so we're now going to square it, so x would be equal to, now x can just be a positive number, so we don't need to worry about negative roots here, so it's going to be equal to the square root of 20.68965 and so on, and when we do the square root of that, the square root of answer, that's equal to 4.548588261. So that means that this length here of x is equal to 4.548588261 centimeters. And that's it. And there's the question asks, give it the two decimal places. No, I'm just going to round this. I'm going to round it to two decimal places. So I've got 4.55 centimeters to two decimal places to two decimal places. And that's it. Okay, let's look at our next question. Okay, so let's have a look at our next question, question number 13. Now, question number 13 is a non-calculator question, so I'll put down my calculator, and we're dealing with algebra here, and it says that AOB is a sector of a circle, so AOB is a sector of a circle, centre O, and we've been asked to write an expression for the area of the sector AOB, so we want to write an expression for the area of this sector. So the area of a sector is beta over 360 multiplied by pi multiplied by the radius squared. In other words, the fraction of the whole circle. So beta, that's going to be equal to 120. Now I can see that's a third of a circle because 120 plus 120 plus 120 is 360. So this is a third of a circle. And whenever you do loads of these sector questions, you get to spot that. Multiplied by pi multiplied by the radius. Now the radius is 9x minus 3. So I'm going to write 9x minus 3 in brackets squared because I have to square this radius. So I'm just writing it in a bracket squared. Okay, 120 over 360, we can cancel that down. That's a third, so I'm just going to replace that with a third. Multiply by pi, and then multiply by, and we've got this bracket squared. Now, whenever we're squaring a bracket, we multiply it by itself. So I'm going to write 9x minus 3, and then in brackets 9x minus 3, because I'm multiplying the bracket by itself. Okay, so what I'm now going to do is I'm going to expand these brackets. I'm going to go down here. So I've got a third, multiplied by pi, multiplied by, and let's expand the brackets and see what we get. 9x times 9x is 81x squared. 9x times minus 3 would be minus 27x. Minus 3 times 9x would be minus 27x. And then minus 3 times minus 3, well, negative times a negative is a positive, so it's going to be plus 9. Close brackets. Okay, so we've now got a third, multiplied by pi, multiplied by, and let's work this out. So we've got 81x squared. And then minus 27x, take away another 27x, would be minus 54x. And then we've got plus 9. Close brackets. Okay, so we've now expanded our brackets. We're now going to multiply by pi and also multiply by a third. Now, multiplying by a third, that's the same as dividing by 3. If you multiply something by a third, it's the same as dividing by 3. So let's divide all of these terms by 3. So if we do 81x squared divided by 3, well, 81 divided by 3 would be 27. Let's just check that. 81 divided by 3. How many 3's go into 8? 2. Remainder 2. How many 3's go into 21? 7. So it's going to be 27x squared. I've still got to multiply by pi in the front. I'm just getting rid of this a third by dividing all these terms by 3. Then minus. Now we need to do 54x divided by 3. So 54 divided by 3. How many 3's go into 5? 1. Remainder 2. How many 3's go into 24? That's 8. So it's going to be minus 18x. And 9 divided by 3 would be 3. So plus 3, close brackets. And that's it. Now we could expand this if we wanted to get 27 pi x squared minus 18 pi x plus 3 pi. I probably would just leave it like this. And then it would be centimeters squared. So that would be my expression for the area of that sector. Pi times 27x squared minus 18x plus 3. Or as I said, you could write it as 27 pi x squared minus 18 pi x plus 3 pi centimeters squared. And that's it. Okay, so let's have a look at our next question, question number 14. So question number 14, we've got this sector, and we're told the area of the major sector, so that's this region in here, is 180 centimeters squared. I've been asked to calculate the perimeter of this major sector, so we want to find the perimeter of this major sector. So that means we need to find this length, which is the radius of the whole circle, this length, which is also the radius, and then this length here, which is the arc length of that major sector, and then add them together to get the perimeter. Now, in terms of this question, well, we know this is 120 degrees here. In terms of the angle in here, these two angles meet at a point, so we're going to take the 120 away from 360, and that's equal to 240 degrees. So this angle is 240 degrees. Okay, now in terms of this major sector, we know its area. So if we know its area, we can then find its radius because we know its angle. So the area of this sector is equal to beta over 360 multiplied by pi multiplied by the radius squared. Okay, so let's substitute in some values. So the area is 180 is equal to beta, that's 240, so 240 over 360. Actually, that's 2/3 of a circle because 240 over 360 cancels down to be 2/3, and I know that because 120 is a third of a circle. Multiplied by pi, multiplied by the radius squared. Okay, so let's work out what the radius is. 240 over 360, we can cancel that down to be 2/3. We're going to get 180 is equal to 2/3 multiplied by pi multiplied by the radius squared. Now I'm going to multiply both sides by 3. So if I multiply both sides by 3 on the left hand side, I'm going to get 540 is equal to. Now I multiply by 3 to get rid of the divide by 3, so I'm just left with 2 multiplied by pi multiplied by the radius squared. Now actually at this point I could just work out 2/3 multiplied by pi and then just divide both sides by that if I wanted to, but I would just multiply both sides by 3. I'm now going to divide both sides by 2, so I'm going to get 270 is equal to pi multiplied by the radius squared. I'm now going to divide by pi, so on my calculator I'm going to do 270 divided by pi, and that's equal to 85.943666927, and that's equal to the radius squared. Now as the radius squared, we want to find the radius, we now need to square root this, so r, the radius, is equal to the square root of 85.94 and so on, so the radius would be equal to the square root of answer 9.270580849 centimeters. So that's the length of the radius, 9.270580849 centimeters. That's the length of that radius. Okay, so we found the length of the radius. Now the question wants us to find the perimeter of this major sector. So if you need to go back to Corbettmaths and watch the video on arc length, feel free to do that. Now arc length is quite straightforward. Remember, to find the area of a sector, we just do the fraction of the whole area. So we do the area of the whole circle, pi r squared, and then multiply it by β over 360, the fraction of the whole circle. And it's the same for arc length in terms of the fact you'll be doing the fraction multiplied by the whole circumference. So you'll find the circumference of the whole circle and multiply by the fraction, and that'll give you the arc length. So here we've got this straight line is equal to 9.27058 and so on. We've got this straight line here, as we've said already, is equal to 9.27058 and so on. And then we've got this arc, and we need to find the length of that arc, and we're going to use the arc length formula to do that. So β over 360 multiplied by the circumference of the circle. Some students will use 2 pi r here, and you're more than welcome to write 2 pi r here if you want to. I tend to use pi times diameter, but you could use 2 pi r, it's up to you. Okay, so it's the fraction of the circle multiplied by the circumference of the circle. So here you could do pi times diameter or 2 pi r. So β, well, β is 240, so 240 over 360, remember 2/3, multiplied by pi multiplied by the diameter of the whole circle. So we've got our radius. If we just double that, now it's already on my calculator display, so I can do multiply by 2, and that's equal to 18.5411617. So that is the diameter of the whole circle. Now we just need to work this out. So on my calculator, I'm going to do 2/3 or 240 over 360 multiplied by pi multiplied by the diameter of the whole circle. And again, that was on my calculator display, so I can just press answer, and that's equal to 38.83251825 centimeters. So that's the distance from here around to here, going around this way, is equal to 38.8325 and so on. This is fantastic. We've got this radius, we've got this radius, and we've got the arc length. So in terms of the perimeter, we just need to add them all together. So let's do that. So let's go down here and add them together. So it's going to be 9.27058 and so on, plus 9.27058 and so on, plus 38.8325 and so on, and that's equal to 57.3736 and so on. Now the question says to give our answer to one decimal place, so our answer will be 57. Now we had 37, so we're going to round up to 0.4 centimeters. And remember, it's perimeter, and in this case that'll be in centimeters. And that's it. So we found the perimeter of that sector. Okay, let's look at our last question. Okay, so let's have a look at question number 15. So question number 15 is a calculator question, and we're going to have to use our calculator in this question. And we've got shown below is a kite. So this is a kite OCDE. So OCDE. And actually, if we turn our head sidewards, the kite, the line of symmetry is going down this way. So we can see here, that's the kite like so, where you've got the line of symmetry going that way. Okay, and we're told that OCE, so OCE is a sector of a circle, center O. So here we can see this is a sector here. And we're told that CD, so CD equals DE, so that's 25 centimeters there and there. And we're told that CE is equal to 16 centimeters. So that line going straight across from C to E is 16 centimeters. We're then told the angle COE is 94 degrees. And we've been asked to calculate the area of the shaded region. So we want to find the area of this shaded region and to give our answer to 2 decimal places. Okay, so what I'm going to do to find the area of the shaded region, I'm going to find the area of the whole kite. So I'm going to find the area of the whole kite, and then I'm going to find the area of this sector, so this sector, and I'm going to take the area of the sector away from the area of the whole kite to find the area of the shaded region. Now the area of the sector will be quite straightforward once we work out its radius. At the minute we only know the angle and this distance here. We don't actually know the radius of that circle, so we need to find the distance OE or OC, and then once we know that we can find the area of the sector. To find the area of the kite, what I'm actually going to do is I'm going to split this kite up into 2 triangles. So I'm going to cut it across horizontally like so. I'm going to get my ruler and pencil and I'm going to cut it across this way here. And the reason I'm going to cut it across that way is I'm going to, for this kite, I'm going to find the area of this triangle on the top. So remember this whole kite, I'm going to find the area of this triangle on the top, this triangle here, and the area of the triangle below. Now there's a line of symmetry, so those 2 areas will be the same. I'll then add them together to get the area of the whole kite and then take away the area of the sector. Okay, so we need to find some measurements here. We need to find this distance here from O to D, because we need to find that for finding the area of the triangle, because remember we're going to do half the base times the height. And we also, very importantly, need to find the length from O to E. Okay, so I'm going to start by finding the length of O to E, the length of this distance here. Okay, so here we've got the length from C to E, this distance here is equal to 16 centimeters. So this line, we'll cut that line at a right angle. So that's a right angle there. And that means that the distance from here up to E will be equal to 8 centimeters. So this distance is 8 centimeters. Also, because this is the line of symmetry, this line will cut this angle in half. So this angle here will be 47 degrees, half of the 94. So here we've got a right angle triangle. We've got a right angle triangle and we've got the length of one of the sides. We've got an angle, so we can use trigonometry to find the length of this side here, OE, which will be the hypotenuse because it's opposite the right angle. Okay, so let's use trigonometry here. And if you need to recap on trigonometry, go to Corbettmaths and watch the video on trigonometry. Okay, so in terms of finding the length of this side, well, let's label the sides of this right angle triangle. Okay, so here's the right angle. So the side opposite the right angle will be the hypotenuse. Here's the angle, so the side opposite it, the 8 centimeters, will be the opposite, and this distance from O to here will be equal to the adjacent. Now in this question, we've been given the opposite. We're trying to find the hypotenuse. We're not using or trying to find the adjacent, so we can cross that out. So that means in this question, we're going to be using sine. We've got skipped over heaven. Sine is equal to the opposite divided by the hypotenuse. Let's write that down. The sine of the angle is equal to the opposite divided by the hypotenuse. Remember, so if we're dealing with our trigonometry, we write down our trig ratios. 2 old angels skipped over heaven carrying a harp. In this question, we weren't using the adjacent, so we crossed those out, and we're using the trig ratio skipped over heaven. Sine is equal to the opposite divided by the hypotenuse. Okay, so we've written that down. Sine of the angle is equal to the opposite divided by hypotenuse. Now let's substitute in our values. The sine of theta. Well, theta is the angle, which is 47 degrees. So the sine of 47 degrees is equal to the opposite, which is 8, divided by the hypotenuse, which is what we're trying to find here. We want to find the length of that side. I'm just going to call it x for the minute. So we want to find the length of the hypotenuse here. So I'm just going to call it x. Okay, so we want to solve this equation. So if we want to solve this equation, we want to find out what x is. So we don't want the x on the denominator. So we're going to multiply the left-hand side by x. I'm going to multiply the right-hand side by x. So on the left-hand side, with sine 47, we're multiplying it by x. That's the sine of 47, I'm just putting that in a bracket, multiplied by x is equal to, and on the right hand side with 8 divided by x, we're times it by x, we'll just be left with 8. Okay, so this is fantastic. We've now got the sine of 47 multiplied by x is equal to 8. So if we want to find out what x is, we need to get rid of this multiplied by the sine of 47. So we're going to divide by the sine of 47, and we're going to divide by the sine of 47. So on the left hand side, we'll be just left with x, and on the right hand side, we're going to have 8 divided by the sine of 47. And then if we type this into our calculator, 8 divided by the sine of 47, that's equal to, x will be equal to 10.93861969 centimeters. So that is the length of OE. So we've now got the length of OE, which is fantastic. So now we can work out the area of sector OCE. So because we know the angle and we know the radius of that whole circle. Okay, so the area of the sector, the area will be equal to theta over 360 multiplied by pi multiplied by the radius of the whole circle squared. So theta is equal to 94 divided by 360, multiplied by pi, multiplied by r, which is the radius of the whole circle. So that's going to be equal to OE, which is equal to 10.9386169 squared, the radius squared. So let's work out what this is. And when we work this out, we get that's equal to 98.15225276 centimeters squared. So that's the area of the sector. Okay, so now let's consider the area of the whole kite. So we've cut it in half, and we want to find the area of the triangle on the top, and we want to find the area of the triangle on the bottom, which will be the same, and then we can add them together to find the area of the whole kite. Okay, so what I'm going to do is, we know the height of the triangle is 8 centimeters, but it'd be great if we knew the base of the triangle, so if we knew the distance from O to D. And to do that, what I'm going to do is I'm going to find the distance from here. I'm just going to call this point M here. So I want to find the distance from D to M to begin with, and then I want to find the distance from O to M, and then add them together, and that'll be the distance from O to D. Now, in this question, there may be different approaches in terms of how you tackle this question, but this is just an approach which will work. Okay, so I'm going to change color pen here, just because we're now going on to the kite. So here, what I'm going to do is let's find the distance from O. So let's find the distance from D to M. So as you can see here, we've got a right angle triangle. EMD is a right angle triangle. We know this distance, one of the shorter sides is 8 centimeters. We know the longest side opposite the right angle is 25 centimeters, and we want to find this distance here. Let's just call that y. Okay, so in terms of Pythagoras' theorem, a squared plus b squared equals c squared. So 8 squared plus y squared will equal 25 squared. Now let's work this out. 8 squared is 64 plus y squared is equal to 625. And then if we take away 64 from both sides, we get that's equal to 625 minus 64 is equal to 561. And then if we square root that, we're going to get that y is equal to the square root of 561, which would be equal to 23.6854 and so on centimeters. So that's the distance from D to M, 23.6854 and so on. Okay, now we need to find the distance from O to M. There's a couple of ways we can do that. We could use Pythagoras' theorem looking at this triangle, and we could use the 8, our answer of 10.9386 and so on, and then use Pythagoras' theorem to find the length of that side. Or we could use trigonometry again. We could label the sides again and use trigonometry again to find this distance here. It's really up to you. I'm going to use Pythagoras' theorem. So here we've got this right angle triangle. We've got this distance here. One of the shorter sides is 8. We want to find this shorter side, and the longer side opposite the right angle is equal to 10.9386169 and so on. Okay, so let's use Pythagoras' theorem. So let's call that length here z. So we want to find the length of z here. So let's write down Pythagoras' theorem. So we've got 8 squared plus z squared, what we're trying to find, is equal to 10.93861 and so on squared. Okay, if we square both of these, we're going to get 64 plus z squared equal to, and when we square this, we get that's equal to 119.6534007. Now we want to find out what z squared is, so let's take away 64 from both sides. So z squared is equal to, if we take away 64, we get that's equal to 55.6534007. Now that's z squared. Let's square root. So let's scroll down a bit. It's a bit messy in this one. So z will be equal to the square root of 55.653 and so on. And that means that's equal to the square root of answer is equal to 7.4601 and so on centimeters. Okay, so this is fantastic. We now know that this distance from here to here is 7.4601 and so on. So we've got the distance from D to M, we've got the distance from M to O. If we add them together, that'll now be the total distance from D to O. So let's do that. So let's add them together, and we get the DO is equal to, so if we write this down, DO is equal to 23.6854 and so on, plus 7.4601 and so on, and that's equal to 31.14555.925. So that's the distance from D to O. Okay, now we can use that to find the area of the triangle, because we've got the length of the base and the height. We do half the base times the height. We'll get the area of triangle DEO. So let's do that. We've got half the base times the height. The base was our 31.145 and so on. The height of it was 8. And when we do that, we get an answer of the area of that triangle to be 124.582237. So that's the area of this triangle, 124.58 1.52237. That's the area of that triangle on the top. So then if we double that, we'll get the area of the whole kite. So let's do that. And when we multiply by 2, we get that's equal to 249.164474 centimeters squared. So that's the area of the whole kite. Now that's fantastic because we've got the area of the sector. We've got the area of this sector here to be equal to 98.15 and so on. We've got the area of the whole kite, which is 249.16 and so on. And if we take them away, we'll get the area of the shaded region. So let's do that. So 249.164474 subtract 98.15225276 is equal to 151.012213 centimeters squared. And that's it. That's the area of that shaded region. Now we've been asked to give our answer to 2 decimal places, so 151.01, and that's it. And that's it. So these have been the video solutions to the area of a sector practice questions. If you need any extra help on the area of a sector, go to Corbettmaths, go to the videos and worksheets section and scroll down to video number 46. Now there were some other videos that you might find useful for this set of questions. They were Pythagoras' theorem, so go to Corbettmaths and look at the video on Pythagoras' theorem, trigonometry, arc length and so on. So those videos might be useful as well. But I really hope you found this video useful. If you have found it useful, please like and please subscribe to the YouTube channel. Thank you. Cheers. Bye.